Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness-of-fit test using goodness-of-fit test and residual analysis. This will actually compare each category with its expected count versus all other categories combined and their expected counts. If you want to compare each category with each possible other category, then that's a pairwise test. I have a separate video on that. I'm using goodness-of-fit test in this case, but you could also use binary test, for which I have a separate video again. I'm using Excel this time with my stikpetE add-in, which is available at my GitHub account. So if you download this file, then open it with Excel. Then in Excel, go for File, Options, Add-ins, and Go. Then browse for the add-in and it should install it, and you should get a lot of additional functions available to you that I've made. The function of interest is the pH post-hoc residual goodness-of-fit test. It takes as input actually only the data as a range, but do not select an entire column, really specify the first and the last row. If you like, you can also specify exactly which test it should be using. Either any of the chi-square tests could be used. I have separate videos on each of them individually. You can also specify some expected counts. Otherwise, it will just assume each category had the same expected count. You can set the correction for multiple testing. Default is Bonferroni, but you can go for CDAC, HOMO, HOLM, etc. For some tests, and then you can also specify the continuity correction, and then you can set it to Pearson, Williams, Yates, or a slightly different version of Yates. For Freeman-Tukey, you can set if you want the modified version. With Freeman-Tukey read the weights, and for power diversions, you can set the lambda. I'll quickly show you the function. So the function itself, I specified the range. As you can see, I listed just the exact rows, and then it actually outputs as an array, so as a range actually. And it gives me all the possible categories, the observed counts, the expected counts. As you can see, in this case, all expected equal. The chi-square test statistic, the degrees of freedom, which is always 1 for this case because it's comparing married to all others, divorced to all others, etc. So there's always 2 categories, 1 and the one selected and all others. -1 would be 1. The p-value and the adjusted for multiple testing p-value. Now, this is the most interesting one, most likely. If this is below a predefined threshold, usually 0.05, we would reject the null hypothesis and claim a significant result. This e minus 240 means I need to divide this 1 by 10 to the power of 240, so that's below 0.05. And actually all of them are except for never married. So never married in the population could probably be just that expected count. While for the other categories, they're all significantly different from their expected counts. As mentioned earlier, if you want, you can actually specify the expected counts. So that's what I've done here. The same range, but now I also have my expected counts in there. The last few columns, by the way, are the minimum expected count, the proportion of cells that had an expected count below 5, and a small description of the test that was used. Last example is where I use a g-test instead of the Pearson chi-square test, and as you can see, we get slightly different results. Alright, I hope this video was helpful, and thank you for watching.